All right, Algebra 2, we are going to work on some quadratic formula today. So here is the formula. When we get together, we're going to sing it because once you sing it, you will memorize it. Okay, so be prepared with your singing voice when you come to class and make sure you are familiar with the tune of Farajaka. Okay, so that's what we're going to get to, quadratic formula. Now, eventually we got to break in and talk about this part right here. This is called the discriminant. So I don't want that to be confusing to you later, but it won't be anything extra. It's just doing part of the quadratic formula to see what happens. All right, so first thing we want to notice is it must be equal to 0. We're used to that right now because we are trying to factor things, and we're going to find out is these things that we have today, they're just not factorable. All right, so let's jump right in here. So here we go. I got to subtract the 4, so this whole thing equals 0. Now I can say that A is 2. B is -1, and C is -4. I don't need this part all the time, but I know, again, this is part of some forward learning last year, so I want to make sure I kind of go over it from the beginning in case you had some trouble with that. We're going to use the quadratic formula. That is -b plus or minus the square root of b squared minus 4 times a times c. It's all over 2a. This is going to give me the x values of the x-intercepts if it has some. So here we go. -b, that's -1 plus or minus b squared. 1 times 1 is 1 minus 4 times a is 2 and c is -4. It's all over 2 times 2, which is 4, right? 2a. So that gives me 4. All right, so there's a couple things that no matter what level I'm teaching this to that I like to see. Go ahead and square this. That means this first item right here is always going to be positive, right? Because even a -1 times a -1 would be positive. I would also like to see, and this is just personal preference, 4AC. Don't try and drive these things together. Reason being, the next thing I'm going to do is I'm going to talk about one negative sign, a positive sign, a negative sign. So if I have two negatives multiplied, that means this should be plus. So I know it's 1, -1 plus or minus 1 plus whatever this number is. Okay, so we're going to take the multiple ideas and make it into one by saying, take care of the sign first. It's all over 4. Okay, so 4 times 4 is 16, times 2 is 32. So I have -1 plus or minus the square root of 33 over 4. All right, and this is where things get a little bit crazy. Can you break down the square root of 33 like we did about a month ago? Okay, square root of 33 is what, 3 and 11, no pairs out of it. That means this is my answer. And you guys are in Algebra 2, so I'm not going to require you to write it, but I want you to be used to the idea. This is -1 plus the square root of 33 over 4, and -1 minus the square root of 33 over 4. Why do I say that? If you're taking the SATs, they are pretty stringent right now about separating the two answers so that you understand that we have two separate answers. Okay, in Algebra 1, we said turn this square root of 33 into a decimal and work with it there. In Algebra 2, we're going to break down the radicals. All right, so that's the quadratic formula. That's how it works. So I'm going to go through that a couple more times here so you can even just try it, pause it, whatever you want to do with it. Since this one factors of 9 that add up to 6, this actually works. So if you don't realize that you're dealing with something that is factorable, you'll see how that works here to give you an answer as well. Okay, so remember A is 1, B is 6, and C is 9. So -b plus or minus the square root of b squared is 36 minus 4 times 1 times 9. I know it sounds ridiculous, right, that we're going to put all this stuff in here, but I know 4 times 1 times 9. Doesn't matter. All right, -6 plus or minus the square root of 36 minus, because there's only one minus sign, and this is 36, and it's over 2. -6 plus or minus the square root of 0 over 2. All right, so the square root of 0 is 0. So here's what we have, -6 over 2, which is -3. But you told me you're supposed to get two answers, Mr. Tola. Yes, they're both going to be -3. Okay, so what can happen is if you get a perfect square like we did here, the square root of 0, all right, so I could say plus 0, but since it's 0, we don't need it. Okay, but if I get a perfect square right here, that means this trinomial that I was working with was factorable. And that's okay. It just means we found another way to do the same problem. It would have been faster just to say the factors of 9 that add up to 6 are 3 and 3, right? +3 plus 3. So my solutions ended up being -3 and -3. right, so that's how it works. We're going to work through just a couple more here and then eventually see how we can apply it. Actually, we'll probably leave that for next time. Okay, so the quadratic formula, we have these two here. Remember, we need to add the 4 over, so I'm going to make this into a big plus sign and equal to 0. Right, and what you'll notice here is the factors of 4 that add up to 4 are 2 and 2. So even though I know this is going to work, I'm going to use the quadratic formula. Negative b plus or minus square root of b squared minus 4ac, right? So if I don't move this over, then I might make a mistake there. 2 times 1 is 2. So negative 4 plus or minus the square root of 16 minus 16 over 2. Well, that's going to be 0. So it's negative 4 over 2. So it's just negative 2 and negative 2. Now, if you only get one of those right now, I understand. And as we start taking a look at the graph, we're going to circle back in this chapter to graph it. And I'll show you why that is what it is and why I'd like to see 2 of them and how that's going to help you later. All right, do we have factors of 3 that subtract to give you 4? No, there's only 1 3 and that subtracts 2. So this one's going to be a full quadratic formula. So either like zoom in, zoom out, make yourself a little more space if you need to. Negative b plus or minus square root of b squared minus 4ac all over 2a, which is just 2 times 1. And don't forget that we would need the a value because that will change as we do some more of these. So I get 16, I got minus, plus, minus, so it's plus, right? Because these 3 guys are being multiplied, 12 all over 2, negative 4 plus or minus the square root of 28. Ooh, I can tell what's going to happen here. We got some extra work to do, my friends. Isn't that exciting? It's exciting. Get excited. Okay, here we go. The square root of 28. What's that made up of? 4 and 7, 2, 2. All right. So now we have negative 4 plus or minus 2 square root 7. It's over 2. And oh my gosh, we're still not done because 4, 2, and 2 all on the outside are all divisible by 2. So this becomes 1. This becomes 1. This becomes negative 2. So what's my final answer look like? Negative 2 plus or minus the square root of 7. I will take that, right? Because that is true. Remember, this is negative 2 plus the square root of 7 and negative 2 minus the square root of 7 when you start looking at your SATs. All right. So that's what we're working on. Quadratic formula. Let's get it done. We are trying to simplify the whole way through. Okay, let me do a quick shout out here. All right, this part underneath here, discriminant. Okay, if it is greater than 0, that means positive. Okay, that means we're going to get 2 solutions, 2 real number solutions. If it is less than 0, that means negative. That means we're going to get no real solutions. We're going to get imaginary solutions. You can take the square root of a negative. So it's going to be that I. And if it ends up being 0, we had this. That means we're going to get 1 solution. And we're going to get that same solution twice. All right. So here's what's happening here. That means if it's positive, we get 2 x-intercepts. Doesn't matter if it opens up or opens down. If it becomes 0, this is the one we're talking about. That means it's going to sit on or just touch that x-intercept. So that was getting the same number twice. And if it turns out to be negative, we're going to get no reals. That means it's not going to go through the x-intercept. All right. So eventually we're going to talk about these as well. Discriminant. What is the number of real solutions? So often we're going to ask for the discriminant, the actual number, and then ask you to translate that into 2 reals, 1 real, or no reals eventually. All right, but I'll backtrack here. Remember, we're just working on this quadratic formula. Make sure you know what the formula is. We can plug it in, and we're ready to roll in class.